Okay, so now that we have learned all three chi-square tests, it is important that you know when to use which test, or how. The how isn't very beneficial, right? So we're going to go ahead and fill in these blanks, and then we'll go through this question I have. So it says both the chi-square test for homogeneity and chi-square test for independence start with a two-way table, right? That's why they're two-way tests. I could spell the word two. Oh my goodness. Let's just change that to 2. They calculate expected counts, test statistic, degrees of freedom, and p-value all the same way. Okay, so even if you pick the wrong test, all those numbers should be the same. So remember, homogeneity test whether the distribution of categorical variable is the same for each population. So that each population is telling us that we're talking about more than one population. And an independence test shows where two categorical variables are associated in some population, in one population. And so some population means that there's only one population. And this is saying that there's more than one that you're comparing. So that kind of ties into then that would be why if the data is from 2 or more samples, if you're talking about more than one population, you got to take more than one sample. Oh wait, I'm just talking and I'm not reading, huh? If the data is from 2 or more independent random samples, it already says samples right there. Sorry, I got ahead of myself. Independent. Then it would be homogeneity. But if it comes from a single, one random sample, then it's independence. So that's the biggest probably way you could decide. Also the wording, if it says association, probably independence. So that's giving you a tip if you're not sure. Now you should know goodness of fit, you should be able to write. And then if you're not sure between these two, I would just write two-way tests. But if you really just don't know, they're all chi-square tests. So let's look at this example. It says, are men and women equally likely to suffer lingering fear from watching scary movies as children? Researchers asked a random sample of 117 college students to write a narrative account of their exposure to scary movies before the age of 13. More than 1/4 of the students said they have some fright symptoms that are still present when they're awake. The following table breaks down the results by gender. So you can see this is a basic two-way table. And then here that gives you a lot more information. So that gives you the observed. And then this is the expected that goes with it. If you did the row total times column total divided by table total. And then this would be your component. So what is that? It's your components you add up. It's the observed minus expected squared divided by expected. That you add up to get your chi-square statistic. So it's just giving you more information. It even gives you your chi-square statistic. So if you add up all these components, it should be that. Gives you your degrees of freedom and your p-value. So always read because they might give you stuff so you don't have to do it. So part A says explain which chi-square test should be done in this setting and why. So we have technically 3 options: goodness of fit, homogeneity, and independence. So you should be able to rule out goodness of fit right away because it's a two-way table. It's not just one variable, it's 2 variables, gender and fright symptoms. So now, is it homogeneity or independence? Well, let's look at how many. Did they take more than one sample or only one sample? If you see, they took a random sample of 117. So because they took one sample, it's going to be a test of independence. So that's what we're going to say. Data was from we'll say chi-square test of independence. Or I'll say for independence. because data was collected from one sample. I feel like I'm getting worse and worse at writing. Okay, so that tells us its independence because it was one sample. Now it says, now that you decided its independence, you should be able to set up your hypothesis for research. So what would your HO be? I like how I ask all questions. I hope you'll answer so I'm not crazy. Your null is no, so there is no association. Between, and now you just write your two categorical variables. The first one is gender, and this other variable is fright symptoms. For the population at interest, which you should be able to write that, or you can actually say, what is our population? What was our sample from? College students. For college students. And our HA is the same thing, but there is an association. Gender and fright symptoms. For college students. Okay, so C says, which cell contributes most to your chi-square statistic? In which way does this cell differ from what the null suggests? So what is that asking? Is what contributes most? It's talking about your components. That's where you look at these component values. So what had the largest component was this one, males that what? Said yes to having fright symptoms. So we will say males who said yes to fright symptoms contributes most to the chi-square statistic. And let's go ahead and write down what that number was, statistic, because it had a component, so they know that you looked at the right thing. Because it wasn't just because it was the smallest number, but it varied the largest from the expected. So it had a component of 1.883. So it says, in what ways does this cell differ from what the null suggests? So what does our null suggest? That there's no association, right? But then this is saying if there's no association, then it differs. Why does it differ so much from the expected, right? So then part D says interpret the p-value, which is, I'm glad we're reviewing this because there was some questions on your assignment about that too. So what is a p-value, right? If you go back, this is an interpretation we wrote on a sticky note a while ago, I think in chapter 9. The idea behind these p-values in these tests is it's the probability, it's assuming your null is true, it's the probability of getting your sample result or something more extreme. So that's why if we get a really small p-value, we think, okay, the chances of getting our sample result is so small that the null probably is not true, right? That's the idea behind these tests. So you always set it up the same way for interpreting the p-value. You say, assuming and I don't have the sticky note in front of me, so I might be switching up the wording, but it should be the same idea. Assuming now the null is true, you just write out the null. There is no association between gender and fright symptoms. The probability of getting our sample result, which sometimes on your AP practice, it's the probability of getting your test statistic, which is the same idea. Your test statistic is just a standard measure of your sample result. The probability of getting our sample result, or something. What do we shade when we do the p-value for chi-square? We shade to greater than. We always shade to the right. So something greater is, what was our p-value? 0.045. So if we use our significance level 0.05, you should be able to do that. So that is smaller. So now, when you draw a conclusion, this was just interpreting the p-value. Drawing a conclusion is what we always do. Our conclude part of our state plan, do conclude. So you should be able to do this one. Since p-value 0.045 is less than alpha, we reject HO, right, because there's such a small chance of getting our sample result that we think the null probably isn't true. And that means we do have convincing evidence that, and now you write your HA, there is an association between gender and fright symptoms for college students. Okay. So that's just kind of breaking down the different ways they could ask it if it wasn't just a normal plain test. This last thing's kind of random. I don't see it too much come up, but I did want to just address it because it's pretty basic. If it does ask, it says, what can we do? Let's say you do your expected counts and they aren't all greater than 5, right? If we have some expected count less than 5, then technically we couldn't do our test. So what you do is you collapse the table. Make sure I'm not forgetting something. By combining 2 or more rows. So only collapse rows and columns that actually make sense to be put together. So if you look here, it's a scenario and it breaks down. One variable is what type of, what by their class they're in, undergraduate, graduate, faculty, staff, or other. And then this is where they checked out books. So this kind of confused me at first. This is main library, undergraduate library, special collection library are your 3 different types. And so this is your observed for main library undergrad, and then this is your, then they also give you the expected in that scenario. So they give you observed, expected for each cell. So it says, in choosing the rows or columns to be merged, you should look to choose values of variables concerned that makes sense, right? So for example, let's say that in the book circulation situation above, if it had different data and you had an expected frequency of 3 in the undergraduate column, right? So here if you look, actually all our expected are greater than 5, but it's saying let's pretend that this is 3. And so we say, oh, our expected count's less than 5. So what you could do is before you do your test, you could merge this column with another one that would make, when you add it together, that it's not, now it'll be greater than 5. Now what would you add that to? It wouldn't really make sense to combine undergraduate and faculty, but you would want to combine it with what is most similar, right? So undergraduate and graduate, we could combine that and be one category and just be, let's say, students. And so now we just have 3 types of this variable and 3 types of this or 4, right? Students, faculty, staff, and other. And you would just combine these, add it all together, and just create a new 2-way table. So I'm not going to actually write anything out. It kind of just explains it here. Just something to be aware of. That's my dog. Hopefully if you made it this far in the video, you get a treat of hearing my dog bark. Hopefully you're going to keep doing it. But this is really it. So this last page is just for you to, it's just a flow chart to help you decide what test you're going to do between goodness of fit, homogeneity, and independence. You're going to start off, is it one categorical variable, just a table, or is it a 2-way table? That's 2 categorical variables. And then from here you would look at is it one sample or more than one sample, and then there's some keywords. You can look through that. If you have any questions, as always, please do not hesitate to send it to me via Remind or Google Classroom or however other way you find to contact me. Okay? So I will keep y'all updated as we keep going through this online situation and AP testing. I should find out soon. I know this is probably crazy for some of you seniors, so really if you need anything stats or not stats related, let me know. But we finished chapter 11, so I will eventually send out a blank chapter 12 notes if you have a way to print it. If you don't have a way to print it, you can just watch and take your own notes, or let me know and I can try to print it and send it to you. But we will address that when we get there. Bye.